Okay, and we have here f of x equals the x plus 1 over x plus 4, all encased in the power to the sixth. So this is, hopefully this is obvious, that this is a nested function. So we have this thing. The inner function is this quotient x plus 1 over x plus 4. The outer thing is the thing it's contained in, which is this thing to the sixth power. So you can think of it as like f of x. Well, let's look at it this way. The outer function is something being raised to the sixth power. So we can think of this as, I'll call it capital M of x. The outer function is x to the sixth. The inner function is the thing inside it. We'll call that b of x. This is x plus 1 over x plus 4. So if I were to take like m of the composition, m of b of x, hopefully you see that I would get x to the sixth, and inside is x plus 1 over x plus 4. So these are what we call nested functions. And to differentiate these, we have to use the chain rule. Now, when I learned this in high school, I had a really strange calc teacher that always referred to these nested functions as the mom and the baby function. So you can think of this as like the mother and the baby, and when the mother is pregnant, the baby is sitting inside. So the nested inside function is the baby function. So the chain rule really says that to differentiate these things, you're gonna differentiate the mom, leaving the baby inside, then multiply by the derivative of the baby. So if we go to the formula sheet, nested functions like this, here we have the derivative of f of g of x. G is sitting inside f. We differentiate f, but leave g inside, then multiply by the derivative of g. So if I differentiate the mom, let's go back to green here. M prime is going to be 6x to the fifth. If I differentiate the baby, well, that's going to be quotient rule. That's low. This will be b prime. Let's see if I can fit this. Low x plus 4. D high, derivative of this is just going to be 1, minus high x plus 1. D low, derivative of that is just going to be 1 over low squared. So there I have everything I need. Differentiate the mom. So instead of x to the 6, we have 6x to the fifth. Leave the baby inside, which is x plus 1 over x plus 4. Let me clean this up a little bit. Multiplied by the derivative of the baby, which is this thing. The top can be simplified. X minus x, they go away. 4 minus 1 is 3 over x plus 4 squared. And that's going to be your derivative. Okay, I'm going to show you a different example right now of another chain rule problem. So here, same idea. I'm going to call this f of x. I have a nested function. The outer function is this thing, 10 times the square root. That's the mom function, the outer function. So I'll call that m of x. This is 10x to the 1/2, or 10 times square root of x. The baby is the inside, 4x to the 4th plus 5x to the 6th. So if I'm going to differentiate both of these just to have them for my work, m prime is, bring the power down, 1/2 times 10 is 5x to the negative 1/2. Subtract 1 from the power. Differentiate the baby, I have b prime equals 16x to the 3rd plus 30x to the 5th. Now I can write everything out. F prime, differentiate the mom, but leave the baby inside. This is the same thing as 5 over x to the 1/2. So this is 5 over the square root of, 4x to the 4th plus 5x to the 6th. Differentiated the mom, left the baby inside, multiply by the derivative of the baby. 16x to the 3rd plus 30x to the 5th. Now, if you want to make this real nice, you can just multiply the 5 by both of these. This is 80x to the 3rd plus 150x to the 5th over the square root of 4x to the 4th plus 5x to the 6th. Okay, you have to get used to these things not looking pretty because very rarely do they ever end up looking kind of pretty. They're always kind of ugly.